China now claims it has built a space radar so advanced that it can detect U.S. stealth jets like the F-22 Raptor, even through clouds, fog, or total darkness. This claim, if proven true, challenges the very foundation of stealth technology. So how does this radar see what others can't? And what makes it different from every failed attempt before? In this video, we'll explore how China's LT-1 dual satellite radar works and what it could mean for the future of air power. For decades, stealth technology has been the holy grail of air dominance. From the F-22 Raptor to the B-21 Raider, stealth aircraft rely on their ability to scatter and absorb radar waves, making them nearly invisible to conventional detection systems. But there's always been one dream: spotting them from space. The problem? Until recently, that dream seemed impossible. Traditional radars on Earth work by bouncing radio waves off a target and reading the return signal. However, from orbit, signals become extremely weak. The reflection from a stealth jet is minuscule compared to the massive background noise from the ocean or mountains. For years, even the best engineers thought the clutter was too overwhelming to separate from a stealth aircraft's tiny radar echo. In other words, space radar could see everything except what mattered. That's where China's Ludi TANS-1, or LT-1, enters the story. Launched in 2022, it consists of two satellites that work in a bistatic configuration. One sends radar pulses, while the other listens for the return signal. This approach is revolutionary because it separates the transmitting and receiving antennas across a vast distance in orbit. The advantage? It dramatically reduces interference and improves signal clarity. Essentially, it gives radar a new pair of eyes, trained to filter out background clutter. According to Chun Juanli, the chief designer at the Shanghai Academy of Spaceflight Technology, the LT-1 operates in the L-band frequency, which is known for penetrating clouds, fog, and even light foliage. With 4 kilowatts of transmission power, the satellites simulate the ability to detect objects moving as slowly as 50 kilometers per hour, even when those objects are coated with stealth materials. What's truly fascinating is that this isn't just theory. The researchers ran extensive computer simulations based on real radar physics, modeling a stealth aircraft with a radar cross-section of around 10 square meters, which is realistic when viewed from above. And what they found could rewrite the rules of air detection forever. So how exactly did they achieve this? The secret lies in geometry and angle, two words that sound simple, but are the foundation of this entire breakthrough. The research revealed that when radar waves are transmitted and received at different angles, known as large azimuth bistatic angles, the radar cross-section of stealth aircraft can actually increase instead of shrink. That's because stealth coatings and shapes are optimized to deflect radar coming from a single direction, typically ground-based systems. But when radar comes from space, at an angle the aircraft wasn't designed for, those stealth tricks start to fail. The LT-1 system takes advantage of this by having one satellite transmit and another receive from a completely different position. This cross-view perspective enhances the reflection, allowing the radar to pick up signals that would otherwise vanish into noise. It's like shining two flashlights from different directions. Suddenly, the object that was invisible in one beam becomes obvious in the overlap. The team also solved the issue of radar clutter, which has plagued satellite-based systems for decades. Normally, radar signals bounce off waves, mountains, or cities, creating millions of false echoes. To overcome this, China scientists built a new radar clutter model with contributions from Northwestern Polytechnical University, Shanghai Jiaotong University, and SASD. This model simulates real-world reflections more accurately than anything before it, allowing the LT-1 to filter out noise and focus only on what's moving. Even more impressive, the receiving satellite in this system does not transmit signals. That might sound minor, but it's a huge advantage. Since it's not actively sending out energy, it becomes harder to detect and jam, a major benefit in electronic warfare environments. Their simulations showed optimal detection at bistatic angles between 30 and 130 degrees, where background clutter drops dramatically. Within that window, radar can distinguish moving aircraft from the static environment below, even over rough seas. In essence, the LT-1 isn't just powerful, it's precise. This means the once invisible stealth aircraft could now have a visible radar signature, not because they've changed, but because the perspective has. That's the genius behind China's approach. If China can confirm these results through real-world experiments, this technology could reshape how every major military plans its air operations. For decades, stealth technology has been seen as the great equalizer, a way to strike first, unseen and undetected. But if radar satellites in orbit can see through clouds, darkness, and stealth coatings, the world's balance of aerial power might be about to shift. Let's put this in perspective. Optical satellites like Jilin-1, which China used in 2021 to spot an F-22 through clouds, are limited by daylight and weather. They can take pictures, not radar readings. But the LT-1 space radar can operate 24/7, unaffected by light or storms. That's a massive leap forward. It means continuous, all-weather tracking, the kind of surveillance that's invaluable in both defense and early warning systems. Another key advantage is coverage. A single space radar satellite can scan thousands of square kilometers in one sweep. Combine several of them into a constellation, and China could, in theory, monitor entire regions from orbit. This opens the door to a global stealth tracking network capable of watching not just fighter jets, but also drones, bombers, and even cruise missiles that rely on low observability. Of course, there's skepticism. Many Western analysts point out that simulations don't always translate to operational success. The environment in space is complex. Ionospheric interference, signal attenuation, and timing precision all add layers of difficulty. Yet, the Chinese team's research suggests that these hurdles are shrinking. With advances in onboard computing, signal processing, and artificial intelligence, real-time space radar analysis is becoming increasingly realistic. If proven effective, this would have enormous strategic consequences. It could mean the end of the invisible era of aircraft, not because stealth technology stops working, but because observation from space breaks its shield. And that's not just about tracking, it's about deterrence. Knowing that stealth assets can be seen changes how nations deploy them. It forces a rethink of air tactics, mission planning, and even how future aircraft are designed. China's LT-1 radar system may represent more than just a technological experiment. It's a glimpse into the next era of global surveillance. If its capabilities are verified, the idea that stealth aircraft are undetectable could soon be a thing of the past. It shows how space is rapidly becoming the new frontier of detection and defense, where innovation in orbit decides what happens on Earth. Whether this technology proves operational or not, it highlights a powerful truth. The race for invisibility is never over. It just moves to higher ground. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries, and don't forget to leave a comment below. Also, you can visit our website, SpaceEyeNews.com. Thank you for watching, and see you next time.